May June 2019, Paper 2, Variant 2. Question 1. Methylpropane, okay, this one, is an isomer of butane, this one. Part 1. Explain why methylpropane and butane, they are pair of isomers. Okay, so obviously they are structural isomer and they must have the same molecular formula. So which means they will have 4 carbon and 10 hydrogen, same, C4H10. And they must have one different thing, and the different thing is structural formula. Okay, the structural formula for methylpropane is this, butane is this. So this is their different. Part 2. Identify the type of isomerism by the methylpropane and butane. So this one, the main chain is 3 carbon for methylpropane. The main carbon chain is 4 carbon. Therefore, the isomerism is chain isomerism, different in the length of the carbon chain. Part B. So we have this equilibrium between the butane and methylpropane. Enthalpy is negative 8 kJ per mole. State and explain the effect on the composition. Composition means the reactants and products. So which one is decreased or increased later. Okay, when the temperature increased to 473. So initially is 373. Now temperature increased to 473. So means this equilibrium try to decrease the temperature. Okay, so it's not going to go or move forward, because move forward it's produce more heat. So it won't really decrease the temperature. That's why the equilibrium will shift to left hand side. Okay, because when it shift to left, then its endo, it will absorb the heat, lower the temperature. That's the reason why it shift to left. Okay, when it shift to left, we know that this methylpropane decreased, and of course butane increased. So what you can discuss is, okay, what you can state is the proportion, means which one decrease, which one increase. So the proportion of methylpropane decreases, right, because now is shift to left. Okay, this methylpropane lesser, and the equilibrium moves left because the forward reaction is exothermic. Okay, it shift left because the forward reaction is exothermic. Means when it shift left is endo, it can absorb the heat, lower the temperature. Okay, this is the graph for the butane and methylpropane reaction. Butane is a reactant and the methylpropane is a product. For a reactions, always the reactants decreases and the products increases, right? And after that, they will reach the constant concentration, means equilibriums will establish later, means after this point. Okay, so these two, this concentration and this concentration, they are the constant concentration for both reactants and products at equilibrium. Means when it reaches this concentration, then equilibrium is there, already formed. Okay, so from this graph we know that the one that going up must be the one that formed. Methylpropane is a product, so therefore this curve must belongs to methylpropane. The one that going down here must be the reactant because it's consumed. So we know that this curve is a butane. Okay, label the graph with T, part 1, yeah, with T, to show the time taken to reach dynamic equilibrium. Very easy, this point. After this point, constant concentration achieved. Okay, use the graph to find concentration for these two. Okay, butane, we know that is 0.3 here. And the methylpropane is 0.7. So you just put the numbers here. Okay, write an expression for the Kc for this reaction. Kc, we know that is the concentration of the products over concentration of the reactant. Okay, therefore is the methylpropane over the butane. Must have a square bracket. Calculate the Kc value and its units. Okay, the units is mole per dm cube each. So it will cancel out. So means later it has no units, or you can say dimensionals. Okay, so we substitute the concentration of the methylpropane and the butane, so we get 2.33. That's all for this question. Thank you.